All right, everybody. Hey, thanks for coming in today, and a special shout out to everybody who is here at the morning panel session that we guilted into coming back for the 3 o'clock. Appreciate you guys being here.
Thanks for succumbing to peer pressure, or I guess we're not peers.
Yeah, the shameless plug for coming to the session here. I'm actually super surprised at how many people are here. This is great. I think this is one of the busiest sessions I've been in, so thanks everybody for being here. The focus today is how to get your EV wheels turning. The main focus for this is for EV conversions or building a custom EV from the ground up. And this is going to be a very high level view of this topic. This is not one that can be covered in an hour. We've got lots of other trainings that we do at Legacy EV that can take a deeper dive into this. We're basically condensing like a week of training into an hour. So forgive us as we talk really fast and move through a lot of points, but we'll go ahead and get started. So Tim and I are your instructors for this session today. We went into teacher mode, brought a PowerPoint with us. We also brought some whiteboards and expo markers. This will be hands-on.
Yeah.
Yes, it will.
Yeah, also big shout out to people who grabbed whiteboards. There's still 2 expo pins if someone wants to join.
Yeah.
Do we have to give them back?
You do have to give them back. I mean, if you walked away with them, it would actually save my carry-on a lot of weight, so. Maybe go ahead and walk away with them, actually. We laser cut these yesterday at like 2 o'clock before we got on a plane and came here. So forgive us if there's a little bit of like burnt edge gets on your khakis. You might want to hold it up a little bit.
Campfire.
But yeah, it smells like some burnt wood there. So yeah, Tim and I are your instructors today. My name is Maverick. I'm the president and co-founder at Legacy EV. My background's in education. So I taught at a STEM school and robotics school, and my passion is trying to take complex concepts and making them more accessible to more people. And that's a big mission for us here at Legacy EV. Tim, go ahead.
Yeah, my name's Tim Cashlin. I'm the customer experience manager at Legacy EV, so overseeing the process from initial inquiry through fulfillment and support. My background originally is industrial automation and instrumentation, so motor controls, process controls. I've known Maverick for a long time, and so I joined up with Legacy maybe 2 years ago now. And initially was doing a lot more of the technical work, the wiring, the programming, but now more zoomed out, more business development focused.
Yeah, so today we're going to be just being teachers. That's what our goal is. So we're going to ask you guys to participate in the lesson. You got whiteboards, you got markers. We're going to take this back to like old school classroom techniques. With that, we're also going to pull some tricks out of my teaching tool belt and bribe you guys to participate. We got some stickers. We've got even more stickers here. So after the session, come on up. And for those of you that we notice are just really participating and engaging, we'll give you the big stickers and maybe even a notebook. So we're glad you guys are here. Thank you for being here. So let's start out with a warm-up. This is one we start a lot of our sessions with. We probably got a lot more gas car enthusiasts in here than we do EV enthusiasts. Feel free to work with your neighbor. We're going to give you like 45 seconds to a minute to do this. But just think about if you were going to convert an ICE car or an internal combustion engine car to an EV, like what would get replaced? What's replacing your fuel tank? Write it on your whiteboard, jot down as many things as you can. You can do it kind of like a T-chart where you're gonna make it just like this, put a row for, or a column for ICE, a column for EV. Try and make some one-to-one replacements here. What do you think is gonna swap out? Feel free to chat with your neighbors. Go ahead, we're gonna give you like a minute. Murmurs are acceptable. Talk with your neighbors. We don't. Apologies, my guy. Yeah. If you want to write it down in the notes on your phone, you can hold it up. Welcome in, guys. If you happen to have an expo marker in your pocket, feel free to grab a whiteboard, but we are out of expo markers.
And please don't use your Sharpie.
Yeah. Or maybe do, because we don't want to take them back home. It's okay if you don't finish your list. That's fine. We're going to give you like 20 more seconds. Yep.
Just to put the lunchtime haze behind you, get your brain thinking again.
Yeah. And sound team in the back, if Tim and I are doing anything wrong to get feedback, feel free to yell at us. We're receptive
you
to
can
feedback.
point and we can move.
Feel like a statue. All right, guys, let's bring it back. Go ahead and actually just hold up your whiteboard and show us what you got. I'm working on some old contacts here, so we'll see how well my vision works for me today. Nice. I'm seeing some good stuff here. I like it. Yeah, there we go. I can read that. All right, Tim, let's go ahead and go over some of the common answers we see here. Break it down a little bit for people.
Yeah, absolutely. So, fuel tank. Anyone have any ideas what that's replaced with? Battery, right? That's your stored energy that we're going to turn into kinetic energy to push you in the car down the road or down the track. What about engine control unit? Anyone have any ideas about that? Right. A motor control unit. What about an engine? Motor. What about exhaust?
Air.
Yeah. Get rid of it. It's going to the scrapyard.
It's just gonna make noise if you want.
Yeah,
You could make noise with it if you wanted to.
Stereo.
Shout out Borla.
What about like a radiator? What do we think is happening with that? You're still going to have a cooling system, absolutely. And then a transmission. Yeah, it's going to depend. Most of them are going to have speed gear reduction boxes, single speeds, or in some conversions we're still using manual transmission. What about an alternator? All right, I heard somebody over here, DC-DC converter. Yep, that's stepping down to high voltage power to 12 volts to power all our accessories.
Yeah.
Yep, and then a charger.
Sweet. Thanks, guys. That's a great warm-up. We're also going to do some icebreakers and stuff. And again, the idea here is we like to make this like a classroom. Legacy EV, we do a lot of training. So if you guys come to our facility, we'll do a lot of this stuff with you in our classrooms, walking you through a lot. And welcome in everybody that's coming late. Feel free to grab a seat. We're going over how to get your EV motor spinning today. That's the goal. So here's an overview of what we're going to be covering. We're going to get through as much of this as we can. Apologies in advance for anything we don't actually get to, because there's going to be a lot here. Introductions, check that off the list. It's already done. How to choose the right parts for your EV conversion. How does it all get connected? Safely connecting those systems. And then how to learn more beyond just this session. And then we'll try and leave some time for Q&A at the end. So a brief history of EVs. We had some paper towels up here, which it looks like we didn't point out, so apologies, because you don't have an eraser in your hand. You can use your hand or sleeve, or don't tell the convention center, but yeah. Oh, there you go. Koozie cup. There we go. I like it. Let's just throw this question out there. What year do you think wheels were spinning on the first EV? What year do you think wheels were? Go ahead and just jot it down, and when you got it, kind of hold it close to your chest on your whiteboard so your neighbor doesn't steal your answer. Give you like 30 seconds, maybe 10 seconds. Just be your best guess. All right, and go ahead and show us your whiteboards. 1893, 1910, 1899. We got some good guesses that are real close here. I like it. Yeah, 2012. I like it.
Maybe the first time you could have bought an EV that was fast.
Yeah, I love it. So the first EV, this is kind of a technicality, was actually in the 1830s by a guy named Robert Anderson. Very crude EV. It didn't even have rechargeable batteries. It was really like a carriage with an electric motor. Barely classifies as an EV, but technically that is the first. EVs were around, as many of you clearly know, in the early 1900s. They were actually a very popular type of powertrain when the first automobiles were coming out. They were quiet, they were really reliable, they weren't smelly like gasoline, they were easier to operate, but as roads developed and you needed to go further, they were expensive and they didn't quite have the range, which is, as you know, kind of the Achilles heel still today. Mid 1900s, more EVs like City Car. Late 1900s, we had GM EV1. We even had some like S10s and Ford Rangers that were electric. And then 2006, Tesla came on the scene, and EVs really became known as like a luxury and performance option for people, and adoption really started to skyrocket. And that brings us to today, and we've been converting EVs for a long time. So a lot of people think this is new, but it's actually been around since the 80s, 90s. People have been taking out forklift motors and lead acid batteries and making their own electric car, which is pretty cool. And now today we just are doing Tesla swaps, which is a whole new world. So how to choose the right parts for your EV. Go ahead, Tim.
Yeah, so typically, much in the same way, we're deciding what powertrain we're going to put in a gas car. We're going to look at budget, we're going to look at performance, and most of those are determined by what a motor can output. Thus, the motor is typically the first decision we're going to make in this decision. Once we've decided that, now we can go to the batteries. Different motors have different voltage or current requirements to run, so now we can just select what batteries we want to go with, and then lastly, we can select the charging system. So how much charge capacity do we want, and how quickly do we want to be able to charge? So planning for a build starts with choosing a motor. There's a lot of components that go into an EV, but the best place to start is choosing your motor. Here's why. Like I said before, the battery system will be spec'd to match the inverter's voltage requirements. That's also going to impact other parts of the build, and again, most customers or builders' goals will revolve around how fast, how quickly they want to go.
Yeah, usually when you're trying to build a custom car, you're setting the stage with how much power do you want? Like, what are you wanting to do with this vehicle? And the motor is going to end up determining many other things down the chain of decisions. So if you've got a 120 volt Hyper 9 motor, your battery pack's going to now be 120 volts. Whereas if you do a 400 volt Cascadia system, you got to get a 400 volt battery pack to match it. And so the motor or inverter in technicality is actually going to determine what decisions you're going to make around the rest of your build. This is not the only way to make decisions. It's just often the best way. We're teaching some frameworks here. So we want to hear from you guys a little bit. We're going to do a little art competition real quick. Draw us a picture on your whiteboard. Like, what's a project car that you're interested in building? Or if you got a customer who you think wants to do a cool car, a dream car that you've wanted to build, draw us your best sketch of what that is. And we might ask you some questions about it if you feel confident about your decision. So go ahead and give us a sketch of your best drawing. We'll show and tell the best artwork that we get up here today. Go ahead. Of all the times I've done this activity, I've yet to see one that really impresses me. So I'm waiting for that one today. We got a big enough crowd.
Yeah. The good news is this isn't an art class, so we will still give you an A for effort in the art department.
And like any good teacher, we're definitely not going to give you enough time to actually complete this task with fidelity. So I can say that because I was a teacher for 10 years. Got to keep them on their toes. Got to give them quick timelines. Oh, there we go. All right. Go ahead and turn whatever you got. Show us what you built. Nice. We see some trucks. We see a lot of trucks. We see some racing cars. Love it.
Oh, we're working in 3 dimensions here.
Yeah, I think.
Wow.
I don't know that I've seen I haven't seen some 3-dimensional artwork. Is that a beat up bus back there? Nice. The fact that I could identify that is kudos to you. Wow. We got a boat? Nice. Love this.
Airplane there in the
nice.
back.
I need a little bit thicker line font there, but it's pretty good. Nice. Got some drag cars too. That was great. And again, my contacts are like 4 weeks expired, so the fact that I can see detail on some of those is great. So we're going to take some volunteers here and ask some questions. We want to walk you through the kind of decision sequence that we would do with somebody looking to start a build. So if you had a car in mind that you feel like you know a good bit of the details on, will you like raise your hand? We're going to ask you to interact with us a little bit here. Okay, we got some volunteers back there. You were talking to us earlier. So Tim, let's use you guys as an example. Yeah, I don't know your name, but you were raising your hand. Gray shirt. Yeah. So tell us about your build. What are some of your goals? And we'll reiterate what you say if you don't project super well.
I'm using a Tesla Model 3.
Cool.
1934 Pierce Arrow.
Cool. And what was the build?
It's a 1934 Pierce Arrow.
Oh, sweet. Very cool. So you've already got your build figured out, it sounds like. You know what kind of powertrain you want to use. Tim, do you want to see if we've got anybody who maybe doesn't know what powertrain they're going to use?
Like in this theoretical.
77 Firebird.
Cool.
Cool.
Let's walk through it. So what kind of power and torque would you want for that kind of build?
At least something comparable to what it had.
Okay. Do you know what it had stock?
220 horse.
Okay. Very cool.
It was horrible.
Yeah. Good, good. All right, so that's one metric we're going to look at. Tim, you want to walk through the rest here?
Yeah, the other thing is batteries cost some money. So higher voltage systems need more batteries to hit that target voltage. And also by virtue of higher voltage, there's more potential for danger. And so the other factor we're going to consider there is our battery setup. The next one is fitment and configuration. You could imagine that if you have a front engine front wheel drive car, or a front engine rear wheel drive car, or a rear wheel drive rear engine car, all those kind of motor options are going to vary just depending on what you want to do, especially if we're trying to keep the car mostly stock. You know, if you don't mind cutting it up and time and money is no object, then by all means put whatever you want in it. But a lot of times we're seeing conversions where people are trying to put the electric motor where the old one was, just because that's the quickest path to a conversion.
Yeah. So we've got some specs of different motor systems up here, and they're actually full conversion kits. You can see Hyper 9, Zonic 180, Revolt CR43, and IDM 190. Take a look at those if you can. I know the font's kind of small, but like, talk with your neighbors. What do you notice about just some distinct differences, if you can see those, between each of the options? Go ahead and come up with a few distinct differences you notice between all of them. To talk with your neighbors. Let me see if I can talk more directly into my mic and cut through the super engaging conversations that you guys are having. Thank you. He knows how to get my back with the mic volume there. Thanks, guys. Go ahead and bring it on back here. I'm going to call on some individuals here. What are some things, some distinct differences you notice between each of those system options? Price. Good. What else? We can just shout it out here. We got a lot of people. Go ahead. Output. Yeah. Form factor. We got different types of drive lines that are going to be required. Good. Uh-oh, I dropped my mic. Are we good? Okay, we're good. Good. So all these kits can be used in a variety of applications, and they can have different pros, different cons for using each in a different application. So the Firebird, we wanted 220 horse. We wanted it to at least be better than that, right? So does anybody see, just based off looking at surface level details on these examples, which one seems like the closest fit to keeping it stock? Yeah, Zonic 180, right? You're going to beat it in horse, and the torque is really the number that's going to make this thing feel like it performs, because torque is a great measure of power in an EV. That's like what puts you in the back of your seat right off the line. So Zonic 180, that's a great kit for this, but we noticed that starts at $40K, right? So it's more money than the Hyper 9 system, starting at around $7K. And the key differential there is, there's one thing in particular that's driving the cost difference between those two. Does anybody know what that is? Battery pack size, right? On a Hyper 9, we can get down to a 20 kilowatt hour pack, whereas with the Zonic 180, we're having to start at 60 kilowatt hours. And so that's where, when you're choosing the motor is gonna really determine your battery pack size depending on what kind of battery you're using. So for all these kits, they're using the same modules, they're core power modules, and so the smallest you can get your battery pack is really determined by the voltage and that the motor and inverter are gonna require. So Firebird, great recommendation would be Zonic 180. And if you really want that thing to go fast, you can do a Revolt CR43. That's gonna have a ton of torque, ton of horsepower, but it's gonna have a little bit heavier price tag, right? And then IDM 190, that's a whole different system altogether. It's made to mount transverse in a car, so you're not gonna be able to connect it to the stock drive line, which is rear wheel drive, so it's gonna be a different application. And then I saw the VW bus earlier, and I want to point that out too as a quick example, because it's different, right? Does anybody know the stock horsepower on a VW bus? Right. Yeah. Right. So using a Hyper 9 motor, you're going to get 130 horse, 90 kilowatts of power. That's going to be plenty of power for a bus. And now your kit is starting at 17K, and it's going to be affordable. It's going to be zippy and fun to drive. We've seen VW bus or VW bug conversions done before, where you put those in first gear and you're doing burnouts. And it's like people are amazed because it's a Volkswagen bug and it's doing burnouts in the parking lot, which is not something you see very often. So
It might be just a little bit more reliable.
yeah. Right. So we kind of set the stage with choose your motor first. So that's what we just did. We had a few different build examples we talked about. You're going to have to look at a few factors to really choose your motor. But what else goes into an EV? What else do you need to look at, and what do you decide? So after you select the motor, you got to dive into that. There's more in a motor system than just the motor, right? There's a lot of components that go into it. So we've obviously got our electric motor, but we've also got an inverter. We've got motor controller, motor inverter or coolant kit. We've got a throttle sensor kit, brake pressure kit, high voltage fuse kit, contactors, wire harnesses, and depending on what kind of motor you're doing, maybe even more, right? So there's a lot of components that go into each of these systems that are required to get wheels spinning. And we get a lot of people that call us and they buy a component or two online and then they're like, all right, I'm ready to go. I got a motor. And we're like, okay, we're gonna get you a few more things because you're gonna need a bit more to get wheels spinning.
Quick question in the back.
Is that 17K just motor or the whole package?
Whole package.
Everything required to make the motor spin.
Yeah, good question. And those were honestly just the kits that we sell on our website. So we didn't really talk about this either, but Legacy EV, we're a parts distributor. We're product agnostic. We work with 60 different manufacturers. So we integrate all the components needed to get wheels spinning on a car. And with that, we can work with a bunch of different manufacturers. And so we're not really beholden to any one type of motor. But there are other kits out there that aren't available on our site, which we'll talk a little bit about as well.
Yeah, before we skip ahead here from the motor system, I want to put some emphasis on the inverter. That is, if we're thinking of comparing to the ICE or internal combustion engine, think about it as the valve train and the intake. So Ford famously has the Ford Crate E motor, just sold you the motor, didn't tell you that they're selling you a short block or the equivalent. You still need the brains of the operation, the things that's timing, the things that's converting that DC power to AC power for the motor. So yeah, I just want to emphasize that that's a very important part of the whole equation.
Yeah, and really what we're doing here by showing you this list is it's not ultimately that helpful because you have to make sure all this stuff is spec'd properly to work together. And so really the idea is before you go out and start buying parts, do some research, ask an expert, call a company that sells kits, ask them what you might need because there's tons of help available out there to figure out what's really needed to get the motor spinning. And as the industry has grown, it's become easier and easier to find all this information and figure out what do I really need to get the motor spinning. So we also have a battery system, which we'll start speccing out after your motor system. So go ahead and take this one too, Tim.
Yeah, so first we have our high voltage battery. That is going to be comprised of, I think we're going to dig into that here in just a minute. But so we have our high voltage battery that's going to store our electrical energy. We have our BMS system, that's our battery management system. That's monitoring a bunch of different parameters within the battery, cell health, temperature, so on and so forth. And then all the things that connect all that. So our cell tap harnesses, bus bars, thermistors or like temperature sensors, a current sensor so we know how much current is coming into the battery pack or leaving, charging or discharging. A high voltage disconnect to isolate the battery pack from the rest of the vehicle if you need to do service or work on it. We're also going to have high voltage cable that's rated for that voltage and the amount of current we'll be carrying. Most of these motor systems are running several hundred amps on the low end, up to 1,500 amps on the high end. That is a ton of current. It's about 20 amps that come out of that outlet there. So put things in perspective, we're running big, fat cables. And then also fuses and fuse holders, so to protect the wiring and other components and even people.
Yeah. And we know too that like I can look out in the room and see that there's experts in here that have been doing this for a very long time. We've got Hunter from Netgain Motors here that's that is the foremost expert on the Hyper 9 motor. If you ever have a question that somebody can't answer, you'll end up talking to Hunter at one point or another, no doubt. But we also have people who probably are new to electrical theory and electrical terms. And so normally what we'd be doing in our full course is starting out by breaking down some of the fundamentals of electrical theory. And so we're throwing out terms like volts and amps and watts and kilowatt hours. And we know that those terms may be new for some of you, so forgive us if you don't know what they are. We've got dictionaries online that can define those for you in our courses that you can go through and learn the terms, all that good stuff. Trying to teach to a diverse group of knowledge here. So when you go to select a battery system, at a very oversimplified level, there's two main things that you'll learn or know about the battery systems. There's classifications of batteries, so there's a cell, there's a module, and a pack. And basically that's the different level of battery that you're working with. So a cell is like the most individual level that you'll probably encounter. And then there's the module, which combines a group of cells into one encasement. And then you've got a pack, which combines a bunch of modules into the battery pack. So we saw pictures on the previous slide. The bottom left image, that's a bunch of Tesla modules. So each of those are filled with like AA size batteries, a crazy number of them. I can never remember when I go to talk about this stat, but there's a lot of little,
or something.
yeah, they're called
22 by 6?
Yeah, they're called 18650 cells, and there's a bunch of them in there, and then there's 16 of those modules in a Tesla. And then beyond like the classification of the levels, there's also chemistries. So different chemistries have different nominal voltages and max voltages that you need to be aware of. The main two that you'll encounter are LFP and NMC in OEM EVs and in conversions. Those are the most common types that are used. And again, we could spend a whole hour session going into just the chemistries at least, but we're gonna keep it moving. Go ahead.
Yeah, so when we're speccing a battery system, we're looking at both series versus parallel configuration. So series is negative to positive, so forth, as demonstrated in that top photo there. And then parallel is when we're connecting them, all the negative terminals and all the positive terminals. And so when we're building a battery pack, we're often doing, especially if we're building one from a cell level or a small level, in some cases you're buying modules, you don't necessarily need to worry about that, you're mostly just going to wire them in series, but it's important to know that with series you're going to add up the voltage of the battery. So if we have, in this example here, we have three 12-volt batteries wired in series, we're going to end up with 36 volts. So like if we're looking at the Tesla modules, the nominal voltage on those is like 22 volts. So by the time we put all those in series, you're I think at 350 or so volts nominal for a Tesla. Fully charged, you're at like 403 point something. And then parallel, what that means is you're just going to share the load of current through all the cells in parallel. So within those, if we're going to look back at the Tesla modules, I think those little 18650s, I think there's, I want to say 22, but I might be making that number up, in parallel to be able to share that current load.
Yeah. And so the idea here is when you have a battery pack, you're doing one of two types of wiring for that pack. You're either wiring cells in series or parallel. Well, you're doing both ultimately, but understanding the difference between those is really the foundational level for building a battery for an EV. A lot of times you can buy now like complete packs which have the right voltage and the batteries are already wired in series and parallel. Sometimes you buy modules and then you have to decide, you know, how to wire those together. And there's best practices in handling all of that, which we can again go through more in the future, but understanding the difference between series and parallel is a good first step to doing this, and would probably take more than the 2 minutes that we spent on this slide. So the final system that we're going to talk about is the charging system. And so there's a few different types of chargers. We're going to try and break them down for you. And Tim, we're at the halfway mark, just to let you know. So go ahead and talk about the charging system.
Yeah, so charging systems, you have your onboard charger. That's going to convert your AC power from the grid into DC power. We have our DC-DC converter. We already touched on that. That's converting high voltage power, DC power, to low voltage for our 12 volt battery. We have our charge port. That's typically right now a J1772 plug in the aftermarket, but there are different variations, especially if we get outside of the United States. We have our EVSE, or does anyone know what that stands for? All right, so what's that? Yeah, exactly. So it's like a charging station. So I think it's electric vehicle supply equipment. So a long, hard way to remember charging station. And then we also have some form of charge controller that can be a standalone device or built into a vehicle control unit. Again, high voltage cable, wire harnesses, fuses, and fuse holders.
Yeah. So let's pause real quick. We've thrown a lot of info at you guys in like the last 10 minutes trying to cover a lot here. Do we have any questions? We're going to move on to the next section here in just a second. But we're talking about choosing a kit. You're going to start with your motor, and then you got to choose your battery system, you got to choose your charger system, and you got to make sure they're all spec'd appropriately to work together. So how do you go about really doing that is the question. I'm going to go ahead and I think skip over the charging stuff. Do you want to touch on it real quickly?
Yeah, we can speed run it. So in the United States, because of our electrical grid, we really have three kinds of charging. We have a level 1, that's 120 volt standard outlet. We have a level 2, 240 volt outlet. That's like what you'd plug your dryer or your oven into. And then we also have DC fast charging. It's sometimes called level 3, but I think technically that's incorrect. That requires some specialty equipment, often to the tune of like $100,000 per station installed. So the rest of these, like the level 2, if it's in a parking lot, it's like a couple thousand. And so there is a significant price jump going to DC fast charging, which is why people don't typically have it in their houses. And so when talking about chargers for the EV aftermarket, there really have two options. So we have a level 1 and level 2 charger. Those are typically in the same unit. All right.
We're doing an old switcheroo. Sharing this one, right? Cool. Oh, I didn't turn off my mic. Now I did. Cool. There we go.
It's typically an onboard charger. It can do both level 1 and level 2. So if you're plugged in your garage or at the grocery store, it'll charge the same. Real quick, does anyone know what the most common kilowatt rating for most onboard chargers is? And why that might be?
7.2 kilowatts.
Yeah, these are good guesses.
Yep, so the answer is 6.6 kilowatts. That's typically what's equipped on most OEM EVs, and also I think all three of our or most of them are 6.6 kilowatts. That's because that's kind of the maximum amount of power that your standard 240 volt outlet can put out. So it is possible to go and have like a 12 kilowatt charging system, but then you're going to have specialty equipment installed in your house to take advantage of that. So that's why most are coming in at that 6.6 kilowatts. And then there's DC fast charging, but it's still largely in development in the aftermarket. Expect to see that widely available maybe here within the next calendar year. But for now, we're pretty much stuck with level 1 and level 2 in most cases.
Sweet. So let's wrap up. Like, you're choosing what parts need to go into your build. There's lots of ways to do it. We said you typically start with the motor, then you're going to spec a battery system that goes with that, and then you got to figure out how fast do I want my battery system to charge, and you're going to make sure not to miss any of the little components in between, the fuses, the contactors, the relays, the thermistors, everything that is required to safely operate that system. So there's typically 3 types of kits, and we'll define those for you so you understand when you're looking at the market, like what's available. There's the term crate kit thrown out there often. And the idea between a crate kit is that this is like a plug and play system. It's like something that comes and the junction box is designed and the motor and inverter are already mated and potentially even wired together. And really all you're doing is you're connecting the battery pack to the traction package or the motor package. And it's plug and play. That's the idea. It's a lot simpler to install. The pros and cons of that would be they're more expensive, right? Somebody else has done a lot of the labor to put this thing together for you, but it's bolt in, and it's maybe a little bit less configurable because it's already assembled. So that's one type. A crate package, those are pretty new on the market. We're seeing those really at like a production level where customers can buy them and install them in their cars for, I think, the first time in the last year, if we're having an honest reflection on how long those have been available. The next type of kit is really what we're just calling like an integrated system. And this is like a pallet of parts. It's everything you need to get the motor spinning, but you're gonna have to do some wiring. You're gonna have to read a wiring diagram and put it all together, mounting. It's gonna be a little bit more hands-on, but it also is more configurable and it's a little bit more accessible. And then the third option is DIY. You're going to get your own bill of material. You're going to go find the parts online. You're going to source them. And I think this is the one where we end up getting the most calls around headaches. And it's a transparent, shameless plug that I think the best way to get a kit is to buy a full kit. When we sell them all at the same price you can get them from the manufacturer. So it's really no harm in going direct to a kit distributor because they're getting manufacturer discounts and they're selling them at the same price typically. It saves the builders a lot of headache. We get a lot of calls of like, oh man, I got this BMS, but it's not working. It's not spec'd properly to my system. Or I bought 6 Tesla modules from different people on eBay and now they're all fried because I tried to connect them together and the voltages weren't balanced. So lots of learning experiences to be had there. The simplest way to do it is to buy a crate or a kit, something that is going to get you all the parts you need. So how does all this connect? We'll pause one more time, see if there's any questions out there in the crowd. Sweet, we got a question back there.
I don't know if you're going to touch on it later, but if you had a type of car or lived in a kind of place that had a yearly emissions or safety requirement, how does that interaction typically go?
Yeah, you're talking about like registering it with Department of Licensing and emissions requirements, all that good stuff. It's very state by state, so it's hard to answer that. Like in Arizona where we are, like we can get blue cloud plates for our converted cars, which mean they can go in the carpool lane, they don't have to pay registration fees, and there's no special emissions requirements that they have to pass. We honestly probably have people in this room that might know other states' answers better than that. They're all different. So yeah, Washington, you can get them registered. Washington also just stopped their emissions testing, so I don't know what it would have been like when there was emissions testing there, but happy to help people figure it out. Yeah?
It sounds like California, if you go to the testing center, registration, you can fill out a form, bypass that, they'll give you your registration.
Okay, there's some good info. California, there's some forms maybe you can fill out and bypass some of that info.
Yeah, and the other thing I'd add too is right now this is all pretty new at the scale it is, and so I think a lot of places, governments are still trying to figure out how all this works too. So the answer today might look drastically different a year from now.
Yeah, we've had like government officials come to us with our involvement in training and ask like, all right, if we want to offer a tax exemption for people trying to do a repower, how do we make sure that the repower is like certified or safe? And I think it's a conversation that officials are navigating all the time, and we'll see where it goes as this industry scales. Any other questions?
Yeah. Most of the motors that we're installing now are permanent magnet AC, so they're no longer induction motors. So they are 3-phase, and then typically they're either internal to the rotor or external to the rotor permanent magnets. That's creating that magnetic field, and we're just manipulating the magnetic field in the stator without.
Is that pretty much generated?
Yeah, and that's what regenerative braking is as well.
Yeah, he said it's pretty much a generator, and yep. Yeah, great. All right, so we're going to talk about how to safely connect these systems. We're going to generalize this piece as always, and we can dive more into it too as we go deeper into the education. But really there's 3 systems or 3 categories of systems that you're going to be safely connecting. There's the high voltage DC system, there's the 12 volt DC system, and then there's the CAN bus network. Go ahead, Tim.
Yeah, so high voltage connections, they are always electronically isolated from the chassis and 12 volt system. They do not share the same negative or the same ground. And in fact, there are components that are specific to measure isolation and make sure that those systems are, you don't want 800, 400 volts on your chassis at any time. You're also, because of the high voltage, we can pull less current for a similar amount of power output. That's Watt's law for you. So we're going to use the high voltage system for the motor and inverter primarily, but any other high power accessories. This might include a heater or a AC compressor or a DC-DC converter. If those are running off the 12 volt systems at 1,000 watts, you'd be pulling 80 amps. So always best when you have high power to go high voltage, provided everything's done safely. Everything above 60 volts should be colored orange so that you, the technician, anyone else working on it would know that there's high voltage present. And then lastly, the battery pack should always be isolated via a service disconnect or a battery disconnect of some kind, so you can isolate that battery from the rest of your system. Your 12 volt connections are going to be very similar to what you already have in the vehicle or what you're very familiar with if you're coming from the internal combustion world. As we touched on, the DC-DC converter is going to utilize HV power to keep the 12 volt system charged. It's also used to interface, the 12 volt is used to interface the existing 12 volt system with the new EV system. So typically you'll see like an ignition turn on, or you'll be able to say, okay, under regen situations, we're going to turn on our reverse lights, but those are where those systems start to talk to each other via a 12 volt system. And then also the 12 volt system is going to run your traditional automotive outputs such as lights, wipers, stereo. Could they make an 800 volt light bulb? Probably. Would that be a bad idea? Most certainly. So yeah, that's very similar if you're familiar with automotive wiring at all.
Yeah, and it's interesting too because electric vehicles still have a 12 volt battery. So people that are new to the EV space we get calls sometimes when people are like, oh, my EV won't start. Like, what is going on? And I can't get it to turn on. And we tell them to check their 12 volt battery. It dies and it won't turn on. Can't get the contactor.
Have you ever seen someone driving an EV with jumper cables? They're not, well, you don't know, I guess, but they might just be jumping the 12 volt battery, and hopefully they're not voltage battery. Lastly, we have a CAN bus network. Again, this is technology developed for gas and diesel power plants. It's a distributed system. It's comprised of several different nodes or controllers on a network. This is a reliable and proven communication standard that allows for complex communications between components. So rather than just saying yes or no or an analog value, they can communicate different data points to control things accordingly. And it drastically simplifies the wiring process as only 2 wires need to be ran between components. That's CAN low and CAN high. So this, and in most cases as well, just because the nature of the old systems, this is a separate CAN bus network from, say, what would have been your ECU or your vehicle control system. And so in some cases, you'll actually have 2 separate CAN bus networks that actually communicate via like an ignition 12 volt signal, but aren't necessarily linked together.
Yeah, and as the industry's grown, a lot more controllers have come to market. AEM now has EV controllers. There's the AEM VCU, which has, 4 distinct CAN networks, and can work with a Hyper 9 motor, it can work with a Tesla, it can work with a Cascadia motor, a Zonic motor. So it's widely applicable to a bunch of different systems, and there's a lot of options out there now.
So coolant loops, as we correctly identified earlier, coolant systems are still required in pretty much every EV. Can anyone answer which of these 3 EV systems can benefit from thermal management? Yeah, the answer is all of them. They move a lot of current, through the batteries, through the motor, the inverter, even through the chargers, the DC-DC converters. And so if you want compact, easily managed units, you need temperature control loops. And so in this case, we might have a different like bidirectional valves or different pumps to cool the batteries, different than the motor, but chances are you're still going to be using the same radiator or the same system heater. So all these systems will kind of connect to each other, and in the same way also connect, like if you're going to use the factory radiator, which is something you can totally do, it will interface with the donor vehicle at that place as well.
Yeah, definitely. Does anybody know of an OEM EV that doesn't have an actively cooled battery pack? The Leaf, yeah. Yeah, so not all battery packs have thermal management. Doesn't mean that it's the best out there. Do you guys know, the person you know that has a Leaf, has it ever overheated, the battery pack?
I don't have one, but I know that they have
Yeah.
range and crap.
Yeah. So I mean, thermal management, the better you can like control your heat loss, the better that your range is going to be in the efficiency, so. Cool. So now, how do we safely connect all these systems together? So typically when you buy a kit, you're going to get a wiring diagram that's got a schematic of like, all right, here's your high voltage DC connections, here's your 12 volt DC connections, and here's your CAN network. So you can start going through and figuring out how all these connect together. But there's a safe way to do it, right? So we break our safety procedure, or our safety down into kind of two categories. There's procedural safety, which is like how do you interact with the components that you're installing? And then there's systematic safeties, which are like, what are the best practices when building these things that ensure the driver is going to be safe when they're using the system as well? And both are extremely important. So there's a ton of there's a ton of best practices for the procedural side, and they're not even all listed here. They're all available online, and in a number of online resources. We have them listed in our certified technician program as well. But that's not correct. The first bullet point, I put not in there, and I shouldn't have. Forgive me as I finished this on the plane last night. It should say, do work on a dead system whenever possible. Yeah, really ignore that one. That's the opposite of what you're supposed to do. You should be working on a dead system whenever possible, meaning you don't want a live system when you're wrenching on some lugs. And you want to use lockout, takeout. You want to have a fire safety plan. You want to have people who understand how to use a defib and know CPR. You should never work alone. You should know the system that you're working on, know the voltage and the ratings of everything that you're touching. You should only have one pair of hands on live circuits at a time. You don't want a bunch of people messing with live stuff all simultaneously. And then live, dead, live checks. Anytime you are going to work on something that's live, you want to check your multimeter on something that's live and make sure your multimeter's good. Check that the system is dead, and then check your multimeter on something that's live again to make sure that your multimeter didn't get fried in the process somehow, and then you know the system is dead. And then wear PPE. So there's an exhaustive list of these again somewhere, but these are examples of like procedural practices. How do you know that you're going to interact with the system and do it safely? Personal protective equipment, class 0 gloves, insulated tools when you're working on stuff that's live, which is hopefully very minimal. A shepherd's hook is a good example of like a PPE that's like if somebody's going to be connecting the last bus bar and the system's going live, like have a shepherd's hook ready. It's something that's used mostly on like industrial electrical equipment when you're going to be working on a transformer or something and have it ready for safety. And then the last one's a digital multimeter. We're getting close on time, and I want to give time for Q&A, so I'm moving faster and faster. And when I say know your system, we're talking about understanding the ratings. Like know what kind of wire gauge is supposed to be used, know the IP ratings of the equipment, know what kind of connectors are acceptable and can be used safely on the build. And then, know the safety mechanisms that are required in each system. So these are a little bit more of like the systematic safeties as well. So like you need to have a high voltage disconnect on your battery system. You should have a high voltage interlock on your battery pack. A bunch of stuff that is a systematic safety that you need to have to make sure that the build is safe once it's completed as well. Any questions about that? Yes?
I don't have a question about that, but we can go back one to when you were talking about the cooling system.
Yeah.
If you do a conversion, how long in the morning before you like have a defroster, have a heater, how fast does the system generate enough warmth to take care of the other systems in the vehicle?
Yeah, that's a good question. I mean, it really depends on the vehicle and what kind of heater you have in the car. For an example, I drove a Ford Focus electric that was like a 2014 Ford OEM vehicle, and it had a pretty good OEM heater. Like, I lived in Arizona, so it wasn't that cold in the mornings, but some mornings do get cold, and it would be hot within a few minutes, like the heater blowing hot right away.
Yeah, I live in Michigan, and my Chevy Bolt, if I leave it plugged in overnight, when I get in the morning, I just press a button on the key fob, and it'll start heating the car, and 5 minutes later, it's toasty in there, then you disconnect it from the house. You're not
Yeah.
in the range, off you go.
Yeah, no, that's a good point. With the OEM EVs, like on my Focus, I had a timer, and I said, like, this is my commute time, and my car would warm up for me when it's plugged in before I would even get in. On the conversion side, it depends on the system that you're using. You can probably talk more technically to this than I can.
Yeah, because you can do it two ways. You can either heat via like a heating element, like a ceramic heating element, again using a high voltage, or you can also, if you want to keep your factory system in there, you can heat like a fluid, water, typically, and then circulate that. So it's going to depend on a lot of different things. We've converted a Porsche where the heater was in the back, and then those heat runs through the sheet metal, then up through the dash. And so in that case, took a while because you were heating all this metal. But in other cases, we have a ceramic heater that's just pretty much 6 inches behind the dash with a blower fan on it. So it's going to depend wildly, and you can build your heating system according to what sort of system, what you're looking for as well.
Yeah. Cool. All right. So as we've said, like, dozens of times now, this was obviously a crash course. Very quick. We're talking really fast. We're not interacting with you guys as much as we'd like to, even though we brought the whiteboards, and we did try. We have a bunch of ways to learn more stuff. The first way is, obviously, there's a lot of info out there nowadays. You can go on YouTube and learn a bunch of great stuff. You can go on forums and learn a bunch of great stuff. We also have more education opportunities. We've got online learning that you can do. We've got in-person training. So you can, when you do the in-person training with Legacy EV, you can get access to all the online training. You come to our facility for a week, and we've got these training benches that we've built, which have all the components that you need in an EV powertrain out on a table. You get to mount, wire, commission, test, tune, program, and then do fault finding activities all out on these benches and learn the systems. And we've got different systems on each bench, so you can understand what does it look like to work with a Xonic system with AM controls, or what does it look to work with a Hyper 9 system with the SME X1 controller. So lots of different options there. It's a great way to safely get your hands on components with some experts. And then we got a team of applications engineers that can support people through the build process as well as they're going throughout. So when you sign up for our training, you can schedule Team Finder or Zoom sessions with our applications engineers and pick their brain on what's the best way to wire, what's the best way to build your mounts, a bunch of good stuff that they're always happy to help with. Or you could do training at a partner school. We got Shelby American Automotive Program doing a 2-semester course right now. We've got a bunch more colleges that we're adding next year that use our curriculum, or they use other curriculums out there as well to do EV programs. They're already available online for you to check out. So a bunch of opportunities to learn. There's also a lot of tools out there for you to use: wiring diagrams, installation guides, manufacturer manuals. The manufacturer manuals get better and better. There's a ton of good info out there. The best thing to do is read them. There's a lot of good stuff. And then you can always learn the basics. We got a handbook that walks through, it's like 180 pages of the product agnostic fundamentals. So everything that we tried to cover here in 2 minutes, there's 20 pages on that you can go read and learn more about. So let's open it up to Q&A. We've got like 7 minutes left, which, I mean, we did it. We got through all the slides, some of them a lot faster than we intended. Thank you. Thank you. I was kind of leading. I was pausing enough so somebody would start clapping, and then when somebody did, I was leaning into it, so I appreciate that. Any questions?
When and how much does it cost in your course?
Yeah, so we offer them once a month. Starting in February at our facility in Phoenix. We're also going to SEMA Garage in Detroit, I think in March. Details are still getting finalized on that, but I believe it's the first week of March. You can also check it on our website. We've got a few different options for a cost breakdown. You can do $375 a month for the year, or you can pay up front and do, I think it's $5,000, and then there's a discount as well if you want to pay in cash up front. That includes access to all the online learning, video libraries, wiring diagrams, modules, all that stuff, as well as the consultation from our applications engineers on your first build.
Is there like a certificate
Yeah.
to certify that?
Yep. Yeah. So there's not an industry certification right now from like an official governing body. I don't think ASE has anything but their hybrid EV certification available. So we have an industry certificate. We've got digital badges and certificates that we give. We've got a database that collects all the info. So if you go through our program, you can get Legacy EV certified, and we're working with manufacturers to like give their stamp of approval on that system. So if you wanted to go get a job at one of the OEMs and say, yeah, I'm certified on EV from Legacy EV, that carries weight with them. Question in the back with the black shirt and the baseball cap, yeah.
Since you guys are resellers of 60 different manufacturers, what are areas in which the aftermarket is making an investment? Is it bracketry that, you drop in replacements for whatever, or is it,
Yeah, what I'll say is for sure bracketry. This isn't, right now I could pretty much go buy an LS swap kit for damn near anything, or darn near anything. But right now the industry is so new. A lot of those systems, those bolt-in easy systems haven't been developed. So that's a big thing. And the other thing too, we talk about 60 different manufacturers, but that's not 60 different motors. That's not 60 different controllers. That's across everything. So even if we're talking about like vehicle control units, there's like maybe 2 or 3 compelling options right now. When we're talking battery management, 3 or 4, contactors 2. So when we're saying like 60 is a really good sampling of what the whole industry looks like right now. So don't take away like, oh, there's already 60 people making motors. Well, no, there's like 5 or 6. And there's a lot of space in all these different realms, in safety, in dash interfaces, in,
Yeah.
whatever you can think of at this point.
Yeah, lots of opportunities. Part of our business model is we actually don't do the conversions ourselves. We support the shops that do them with the parts and the training. So we've got a network of like over 40 authorized installers now that do the conversions with our parts. And those shops are, as they're doing builds, they're designing brackets and mounts. And then those shops send photos and specs on those mounts and what builds they're compatible with back to us, and we can now list those on our site so that if we get an order for a C10 Hyper 9 kit and somebody wants a mount, we've got one that somebody's used before and built, and we can work with the shop to fulfill that order, which is another way for shops to try and monetize the opportunities in the EV aftermarket. Yeah, question way in the back. It's growing, so I don't think so, but if there's somebody in here that is one, I apologize. Yes.
battery box material? What is it, everybody, I see them built out of wood most of the time. What's the answer?
I don't think wood is. I think, aluminum or polycarbonate or steel. I mean, there's a lot of different options. The important part there is to make sure that your batteries are isolated from whatever they're enclosed in. And then that box is vented for pressure out, but not moisture ingress in. But there's a lot of different options there, but I think wood would have a pretty limited lifespan.
Yeah. That's a good question, though. Batteries are, I think I've already said this in the session today, but batteries are a little bit like the wild, wild west right now. Like there's a lot of different things happening that maybe aren't the best practice. And as the industry grows, those practices will tighten up and there'll be more standards around what's the best way to do it.
How much inventory do you carry now since they've already get contactors and stuff, so if we need something, you've got it?
Yeah, we've got it. We got a bunch of inventory. I think right now we have 14 Hyper 9 motors in stock. We've got 10 Cascadia motors in stock, Tim's might be looking at me like I'm wrong because he's our sales guy. So he's like, no, we already sold out of all of those.
Contactors, that seems to be the hardest part right now. How are you?
Oh yeah, I think
We got-
between all of our high voltage contactors, 100 plus, 200
Yeah.
maybe.
Contactors out the wazoo.
I think it's important to us to have what people need when they need it. I think a lot of the times what you find in the EV aftermarket is people will go, they'll call, and then that entity will turn around and order it from the manufacturer. So we were, as a way of, I guess, boasting a little bit, we were able to turn around like 8 Hyper 9 kits, like within a week notice, which is pretty much unheard of. And that's because it's important for us to have stock.
Yeah, and as somebody who doesn't manufacture parts, and I see you in the blue, I'll get to you in just a sec so you can put your hand down, I'll call on you. I can tell you're getting tired. As somebody who doesn't manufacture parts, we really just do distribution and training. Like our value add is that we have stock. So we can fulfill orders quickly and we can get you the parts that you need when you need them. Yeah, okay, blue shirt.
So you touched on how batteries are the wild, wild west a little bit. I think we've all seen the pictures of Teslas bursting in flames. Have you guys, or has anybody done crash testing to understand what a converted vehicle will do in the event of an accident?
Yeah, so we have an installer, and you can probably talk to the details better than I can on this, but we've got an installer in Australia. They have a lot stricter guidelines for like classic cars that are being repowered, that they do have to go through a lot of crash testing. They have to like get their battery boxes approved. So there's a lot of stuff there that they have to do. In Australia, we've never done crash testing as like legacy EV, but I think there will come a day when that happens. We actually just had a battery manufacturer contact us and be like, hey, we want to build 2 prototypes and one of them is just a crash. Like we want to see what happens. So I think we'll get there.
A lot of that coming out of the SFI and the sanctioning needing for stuff with an NHRA and all that, all those standards for racing are being developed now for the racing, because obviously that's a higher thing, how they're going to be built, how they're going to be done, and a lot of that information we share and trickle down to, it's like any factor of safety with roll bars, whatever safety equipment you want to do, how far do you want to go and how safe you want to make it, but we should have some better public guidelines for what you need to do. The biggest problem, like you said, Teslas, the biggest thing you have to protect to in an accident in any cell, any technology, is we'll call it, you piff the cell. If you stick a rod test through a cell, you create a dead short circuit with a lot of energy, which is what starts the event. The issue with a Tesla or any battery carrying lot is the problem is not, if the event starts fast and you put it out, it will recombust and do that, and the recovery and everything you have to do and deal with after the event is where a lot of the safety comes in with the first responders and the training. So you'll see a lot of that trickle down from what we need to do to be able
Yeah.
to race these vehicles on the track.
Yeah.
Which will go down.
And as technologies advance, like cells are like vented now at the cell level. So if there is like a thermal event, they're venting, or they've got fire retardant built into layers of the cell sometimes. So cells are becoming safer and safer, which is great.
Yeah, I think what I would add to that, not to discount how dangerous batteries could be as well, but who here has ever seen a gas car on fire? Right? Yeah, so I can go down to the pump and get this super highly flammable thing and no one bats it. It's a new technology. It's under a lot of scrutiny, as it should be, but it's also important to remember that every Tesla that catches on fire ends up on the internet, but not necessarily every gas car does. Mm-hmm. So just to like remember that perspective,
Yeah.
I think is important.
That's good. Yeah, well, guys, we are officially over. I think it's 4:02. So, hey, real quick, if you don't mind returning the expo markers, if you really want to carry the weight and steal the whiteboard, please
the
do.
whiteboards.
We don't have to take it home with us.
We don't want to
Go and
check
bring up
them
the
again.
expos. Hey, we really appreciate everybody coming in today. You can check us out at legacyev.com. If you want to hang around and ask Tim and I questions, we'll hang out for another 10 or 15 minutes and answer questions. Thanks, everybody.